Hi and welcome to the Future of Security. Today we're going to talk about machine learning, or if I dare to say, artificial intelligence, and how Zscaler uses it to provide superior security outcomes for our customers. First, I want to spend a minute and explain the different types of machine learning that we're really talking about, at least on a high level. In general, we differentiate between two types of machine learning, supervised and unsupervised. So with supervised models, what they are really good at is to find similar things. And that requires training, right? So first we have to train these models on what are we actually looking for. So for example, specific types of food. So these models are very, very helpful when you need to crunch a lot of data to find the needle in the haystack, or really a bunch of different needles in a bunch of haystacks. The next type of machine learning model is called unsupervised machine learning model. And that does not require training. So what that type of model is good at is to crunch a lot of data and find out what doesn't belong here. So it really looks for common patterns amongst a lot of data, and it can tell you which one of those data blocks or which data doesn't belong, doesn't fit that pattern in what it observed. This makes these models really good in identifying anomalies or statistical outliers. Why am I telling you all this? Machine learning has some great examples on how we can use it to drive better security outcomes for our customers. So one example, and the most prevalent example, is malware. While we see hundreds of thousands or maybe millions of malware samples on a daily basis, they're all different, all in specific files. They all belong to a very small set of malware families. In this chart, I'm showing you some of the most popular malware families and how they're active over the course of the last 6 months. So while specific files carry the malware, they might look different and they might only last for a few hours. The family and the core functionality has a tendency to stay. So they are really the same thing, just in different shapes, which makes it really, really hard for traditional approaches, signature-based approaches, to catch and detect them. So this is an obvious application for us of machine learning, more specifically supervised machine learning models that we can train on these malware families to detect all variations thereof. So at Zscaler, we really use machine learning in 4 different areas. First of all, we use it to drive intelligent threat prevention, which means use machine learning to identify unknown threats that are maybe related to something we have seen before very, very fast, so customers can block them quickly and don't get breached. The second area is to categorize content inline, content we have never seen before, and we specifically do that in URL filtering, but also in our DLP capability. The third area is behavior-based detection. So we are looking into ways how we can identify suspicious activity, anomalies, with endpoints and end users to drive better security outcomes. And the fourth area, which is also really, really interesting, is we're looking into different ways to use machine learning to improve the user experience and improve administrator experience overall, for example, by making policy recommendations, again, to drive better security results. So today I'm really excited to introduce you to 3 specific applications, 3 specific features that we're working on for our next upcoming release, where we use machine learning to really make a difference when it comes to producing better security outcomes. The first area is our sandbox. Our sandbox has a great capability, which is the quarantine function. The quarantine function allows customers to quarantine a file, let us run an analysis in the sandbox before we pass that file to the end user. This analysis takes a little while, not very long, but it takes a little while to make it a little bit annoying sometimes to the end user. So what we are doing is we're investing in machine learning to identify benign files, meaning files that we know for sure are harmless, so we can let these files go through to the end user, deliver them to the end user while we run the analysis in the background, which is really using machine learning to drive a allow and scan policy versus a quarantine policy. Everything that doesn't fit what is benign, everything that doesn't look harmless, will be held in a quarantine function, which means we won't give that file to the end user until we finish our analysis and make sure this file is either benign or we identify as malicious, at which point we will block it. The second area where we're using machine learning for a specific feature that we're delivering is the inline classification of websites. We have done this before for a while now, and we have supported a handful of categories that we can classify based on the server response, even though we may have never seen this website. So we're expanding the support for these categories, for these URL categories, significantly to hopefully ultimately eliminate the problem of miscellaneous URLs or unknown URLs entirely. I don't think there's any need for us to have a URL that we classify as unknown because we see the server response and we have the tools available to classify all websites. The third area, and this is a really interesting area for us, is malicious insider detection. And what we mean by that is using unsupervised machine learning models to identify outliers in terms of user behavior, to ideally identify the disgruntled employee early on before that employee takes your intellectual property and walks away with it and joins your competitor. So those are really three exciting capabilities that we're working on that we can't wait to deliver to our customers. To summarize, machine learning is really useful in crunching a lot of data to find something that we know or is similar to something that we know, like a face, no matter what facial features you might be able to change, like a beard or dye your hair or whatever the case may be. It can also tell us in a given data set what doesn't belong here, what looks weird, and we can use these capabilities to analyze the vast amount of data we see on a daily basis to identify malicious activity early on so customers can take action and protect their environments and their data and their end users. We're just scratching the surface of how we use machine learning at Zscaler, and we will continue to reshape the future of security.